everyone, welcome back. I'm Domingos. I'm also known as DMA and appreciate when I'm called DMA. So today we have this exponential equation problem to solve. It's an exponential equation whereby we have a square root of ln x all to the power ln x equal to ln x all to the power square root of ln x. Okay, for this particular equation, it is divisible if we apply logarithms both sides. If we introduce natural logarithm both sides. Okay. So if we introduce natural logarithms both sides, that means implementing logs both sides, then we're going to have natural logarithm of this expression being equal to natural logarithm of this expression. All right. We know when we have log of a to the power b, we can send the exponent of the argument at the base multiplying the log of a. Right, so if we apply this rule here, we can send this exponent at the back, then we're going to have ln x times ln of square root of ln x equal to square root of ln x times ln of ln x. All right. But this can be transforming into power, so it could be 1 over 2. This 1 over 2 is still an exponent. We can send at the back, so we're going to have ln x over 2 times ln of ln x. All right. Now, if we check this expression on the right side, we can send to the left side, so it's positive comes to the side negative. Why sending this expression? Because this expression is similar to this expression, so we can factorize it. Since this is equal to this expression, then we can factorize. We have ln of ln x times it's gonna be left with this expression minus the other expression. All right, equal to 0. Now we have the product of two expressions being equal to 0. It's gonna be 0 if at least one of them is 0. So we're going to equal the first one to 0 first. Then what is going to happen? We're going to have, this is ln x equal. We know the base of ln is Euler, so it's going to be Euler to the power 0, which is simply 1. Euler to the power 0 is 1. So here we're going to have x, the base Euler to the power 1, so which is going to be Euler. So first x is going to be equal to Euler. All right. So now let's solve the second equation. This is negative. If we send the other side, we'll go positive. So we're going to have ln x over 2 equal to square root of ln x. All right. So if we square both sides, we're going to have denominator 4 and here square, and the square root we're going to be eliminating. All right. So we can send whether this expression that side or this expression this side to factorize. So we're going to have ln squared of x over 4 minus ln x equal to 0. So if we factorize ln x, then we're going to have ln x over 4 minus 1 equal to 0. So for the first ln x, because they are multiplying, that means the product of two expressions is only 0 if at least one of them is 0. So if we solve ln x equal to 0, then we know that the base of ln is Euler, so we're going to have x is equal to Euler to the power 0. So x is going to be equal to 1. All right, now we have the other problem here. So for this other problem, what is going to happen? We're going to have ln x over 4 equal to 1. So ln x is going to be equal to 4, so x is going to be equal to Euler to the power. So, but if we substitute the values of x in our equation, we're going to realize that x equal to 1 will make ln 0. So 0 to the power 0, it's undefined. So the only solutions that we have is x equal to Euler and x equal to Euler to the power 4. Okay. So if you enjoy, leave your like, your comment, subscribe, and most importantly, share with your friends.